Hi, today is day 151. So countdown to CAT 2020 has already begun and exactly 151 days are left out for the CAT. So we are starting a new series wherein every day we'll be discussing few questions from the Quant as well as DILR section also. So we'll be starting with the Quant today. So these are three questions in front of you. All these three questions are from the geometry and this is IMC. Now, what do you mean by this IMC 1999, which I have written here, or the IMC 2000 here? IIM Kolkata offer two programs. One of them is known as PGP, which is Postgraduate Program in Management, and the other program is PGDCM, that is Postgraduate Diploma in Computers Management. So when you are filling the form of a CAT, make sure that you are applying to both the program here. Earlier, till 2006, IIM Kolkata used to conduct a separate exam for their PGDCM program. You need to clear the CAT. Then only you are eligible for that particular program. So first criteria was clear the CAT. Once you crack the CAT, then you need to write a separate exam for that particular program of IIM Kolkata. So these first two questions are from that paper here. And all the question which was asked by the IIM Kolkata in those years, all those are very, very important. Okay. On couple of occasions, exactly the same question was asked in the CAT also. And vice versa also. Sometimes the CAT question was asked in there and the question which was asked in IMC paper, that was asked in the CAT. So make sure that you solve all those questions. Like question number 1 and 2 and the similar type of the question was asked in the CAT 2008. So I have taken one question, but yes, if you refer to CAT 99 also, there was one question on the similar concept which I am going to discuss here. So before you start looking the video for further, make sure that pause the video for 10 minutes, try to solve all the three questions and then you can start watching the videos. So pause the video right now and solve it for 10 minutes. Try to solve all the three questions. Okay, so let's start with the discussion now. The first question is a box without a lid. So there is an open box. So I can say there is an open box. Has a height of x centimeter. So this box has a height of x centimeter. So I can say the height of this box is nothing but that is x centimeter. So let me write down x and this is x. And a square base of y centimeter. So square base of y centimeter here. And a volume of 500 cubic centimeter. So what is the volume? Volume is equal to length into width into height. So volume here, it is nothing but that is equal to y into x. And this volume is given as 500. So this implies that the value of y square into x, which is equal to 500. Now, also then the question is the value of x for which the least amount of material. So here I am using a least amount of material would be needed to construct the box. So if I need to find out the least amount of material, so what do you mean by the term least amount of material? It means I need to find out the total surface area. Now remember there are 6 faces, but since the box is an open box, so I do not need to take this particular area, the top one. Okay, so I need to neglect the top area. Remember, I need to neglect the top area here. So I can say what is the phase, what is the total surface area? So for the bottom, it is nothing but that is y square, and this face, this is nothing but x into y. So there are 4 faces. Okay, so the total surface area, I can say there are 4 faces. So the area of these 4 faces is 4xy, and the one bottom square face. Okay, the bottom area is x square, not x square but y square. So 4xy plus y square. And our target is to minimize this. This is what I need to find out. Minimum. Okay, so I need to find out the minimum here. Now, so least amount of material means minimum. So what I can do here from this equation, I can say this says that x is equal to nothing but 500 upon y square. So x is equal to 500 upon y square. Substitute this value of x here. So what will I get? Total surface area T. 4 into x is nothing but that is equal to 500 upon y square into y plus y square. Now, if you solve this, what will I get here? 4 into 500 is nothing but that is 2000. So, 2000 by y, okay, plus y square. Alright. And this I need to minimize. Now, there are two different ways to solve this here. If I need to minimize here, one of the ways is differentiation. But remember, CAT doesn't expect you to know the differentiation. So try to solve this question without differentiation. Most of the engineers are comfortable with the differentiation, so definitely you can use the differentiation. So I'll use both the method. One is without differentiation and one is with differentiation. How can we solve it here? Alright. So just see here how we can solve it. Now, so t is equal to this one. Now the sum needs to be minimized. So if I need to minimize the sum, then we should know what is the product here. Can I say that this total surface area, it can be written as what? If I try to write down this total surface area, 2000 by y, I can write down this as equal to 1000 by y plus 1000 by y plus y square. Now, what is the product of these three terms? Okay, if you try to find out what is the product of these three terms. So, if I say the product, that is 1000 by y into 1000 by y, okay, 1000 by y into 1000 by y. And the product, not 1000 by y, but the third term is nothing but that is equal to y square. Okay, so third term is nothing but that is equal to y square. So let me make a correction here. Third term is y square. Okay. Alright. So 1000 by y into 1000 by y into y square. So this is 1000 by y into y square. Now the product of this, it is coming out to be equal to nothing but that is 10 raised to the power 6. And the product of the three terms are constant. And we know one thing, that if the product of the numbers are constant, then their sum is minimum when all the numbers are equal. So the product of these three numbers, it is nothing but 10 raised to the power 6. So product of these three numbers is 10 raised to the power 6. So it means what? That each of the term, it is nothing but that is equal to how much? 10 square. So this is equal to 10 square, this is equal to 10 square, and this is equal to 10 square. So 100 by y, it is equal to 10 square. So if 100 by y is equal to 10 square, what is the value of y? So I can say, or from here you can say that y square is equal to 10 square. So y square equal to 10 square, so this implies that y is equal to nothing but that is 10 here. Alright, y is equal to 10. Or even from here also you'll get the same value, that 1000 by y is equal to 10 square, so I'll get again from here y equal to 10. So when you're using this concept, make sure that from all the three terms are equal. So from each of them, I should get y equal to 10. In case from one of them you are getting y equal to 10 and y equal to 5, then it means that is not possible. So here all the three are equal. So I'm getting y equal to 10. So what is the total surface area? The question here is, okay, what will be the least amount? So the total surface area in this case, it will be comes out to be how much? I can say total surface area, which is equal to 2000 by y. So 2000 by 10 and plus 10 square. Okay. But the question is not total surface. I need to find out what is the value of x here. So we know that y is equal to 10. So if y is equal to 10, you can substitute the value of y in this equation. Okay, let me highlight which equation I am talking about. So this equation, you can substitute the value of y. So if you substitute the value of y, which is equal to 10, so 500 upon 10 square. So 500 upon 10 square means what? That is 500 by 100, and 500 by 100 is equal to 5. So the correct answer for this question is option D, which is 5. So I hope that this is clear to all of you. Now, like I told you, there is one more approach, that is what? This is known as the differentiation. So you can even solve this with the help of the differentiation also. Just see how we can apply the differentiation. Okay. Now, so in this case 2000 by y plus y square. If you take a differentiate, if you are going to differentiate this equation, then differentiate this equation with respect to y. Okay, so just give me a second and I'll differentiate it with respect to y. Alright. Okay. Now, so if I differentiate with respect to y, so I'll get that is dt upon dy is equal to differentiation of 1 by y, it is equal to minus 1 by y square. So minus 2000 by y square, and plus differentiation of y square is equal to nothing but that is 2y, and put it equal to 0. So if you put it equal to 0, what will I get here? I'll get, if you solve this equation, we'll get the same value of y, which will be equal to nothing but that is 10. So when you differentiate it, and by putting it equal to 0, you'll be getting y equal to 10. So now again substitute this value y equal to 10 here, and you'll get that x is equal to nothing but that is 5. I hope that this question is clear to all of you. So for solving such type of the question is to know the basic formulas, and the other concept is the maxima and minima. And most of the time you'll be needing the product is constant, sum is minimum, or sum is constant, product is maximum, or you can also use the differentiation. If you are comfortable with differentiation, use differentiation. That is a quicker way to find out the answer. Now let's move to second question. Second question says a traveling executive wishes to construct a conical tent of a given volume using the minimum possible amount of canvas. Okay, so he's preparing a canvas by using a minimum possible here. Now, so what I can say here is minimum possible amount of canvas. So minimum amount of canvas means what? I need to find out the lateral surface area, because if there is a tent, so I need to cover this tent here. So we need a cloth. So that is basically we need to find out the lateral surface area. So what is the lateral surface area? Lateral surface area of a cone is equal to pi into r into L, where r is the radius and L is the slant height. For example, I can say like this. So this is slant height, which is L, height of this cone is h, and the radius of this cone is r. Okay, and of a given volume, that is also given to us, that the volume is nothing but it is given. So our volume is basically fixed, the volume is constant here. So given volume and minimum possible amount of canvas. Okay, so now, so lateral surface area, it is equal to pi r L, and we need to find the minimum possible value of this lateral surface area. Now what is the volume? We all know the volume is always equal to what? 1 by 3 pi r square h. Okay, so from here can I say r square h, and volume it is nothing but that is my some constant. So r square h, it is equal to nothing but that is volume into 3 by pi, and volume is constant, so v into 3 by pi, it is also going to be some constant. So basically r square into h is constant. And also in the cone we know one thing, that is r square plus h square, it is always equal to L square. So these are the two things which we are aware of. R square plus h square equal to L square, and r square h, it is equal to constant. Now let's see it here, all of you. Now I need to minimize. So what is the lateral surface area? I will write down L or LA, lateral surface area, pi r L. So can I write down, we know the value of L in terms of r and h. Okay, so L is equal to what? L is equal to nothing but I can say pi r into L is equal to root of r square plus h square. Okay, so this is equal to pi into root of. If you take this r inside, what will I get here? That will be r square into r square plus h square. Okay, so I can say lateral surface area, it is equal to pi into root of r raised to power 4 plus r square h square. And if my lateral surface area is minimum, if the lateral surface area is minimum, it means what? That the term inside the square root, it should be also minimum. So we need to minimize this value, that is r raised to power 4 plus r square plus h square. Alright, so now just here how we can minimize this thing. Okay, now, so this is, now we know that r square h is constant here. So r square h is constant. Now can I say r square h is equal to constant here? Okay, and we need to minimize this. So this term, which is here, that is r raised to power 4 plus r square h square. So can I write down this term as equal to nothing but that is equal to r raised to power 4 plus r square h square by 2 plus r square h square by 2. So I need to minimize this expression. So I should know, I need to find out the sum to be minimum. So for sum to be minimum, we should know what is the product. If the product is constant, then sum is better. So we always need to manipulate the equation in such a way that the product of these three terms is constant here. And we know that r square h is constant. So if we multiply these three, let's say multiply this term, what will I get? R square into r square h square by 2 into r square h square by 2. And what is the multi-product? Product, it will be r is repeating how much? R is to power 6 into h raised to power 4. So r is to power 6 into h raised to power 4 by 4. And what is r is to power 6 into h raised to power 4? Can you say this is r square, this is r square h square. Okay, r square h square. Alright. So r is to power 4, no, this is r is to power 4. So just make a small correction. This is r is to power 4. So the product here is r is to power 8 h raised to power 4, which is r h square raised to power 2. Okay, or I can say r square h raised to power 4 by 4. And we know one more thing here, that the value of r square h, it is nothing but that is constant here. So let me highlight that which part I am talking about. This r square h is constant. You can see it here. So this entire product is actually nothing but that is constant here. So this entire product is nothing but that is constant. So I can say the product of these three terms is constant square upon 4. 4 is also constant. So constant square upon 4, that is also constant. So this product, you can say this is basically some constant. And if the product of three numbers are constant, then the sum is minimum when all the three numbers are equal. So if all the three numbers are equal, I can say which three numbers here I am talking about, that they are equal. Let me highlight that. So the three terms, that is r to power 4, which is equal to r square h square by 2, which is equal to r square h square by 2. So these three terms should be constant, this, this and this. So equate these two. So if I equate these two, what will I get here? I'll get that is equal to nothing but I need to, okay, that will be equal to h square by r square. So h square by r square, and that will comes out to be equal to 2. So this implies that the value of h by r, it must be equal to root 2. Okay. So if it is equal to root 2, then I can say this is equal to root 2 here. H by r is equal to root 2. And the question was ratio of height to radius such that we are needing a minimum possible amount of canvas. So ratio of height to radius is nothing but root 2 is to 1. So the correct answer for this question is option D, which is root 2 is to 1. So I hope that this question is clear to all of you. Now let's move to the third question, which was asked in CAT 2008, again based on mensuration and the maximum minimum. It says consider a right circular cone of radius 4. So radius of this cone is 4 here, and the height of this cone is 10. So you can see I have assumed the height of this cone is 10 and the radius is nothing but that is 4. A cylinder is to be placed inside the cone with one of the flat surface resting on the base of the cone. So you can see I have drawn here. And I need to find out the largest possible total surface area. Okay. So we need to find out what is the largest possible total surface area here. So we should know what are the different formulas for the total surface area. Alright. So now, first of all, if you look at here. Now, so I can mark this as, let's say this is P. Okay, this is Q, this is R, this is S, and this is T. So you can easily observe that the triangle PQR, here the triangle PQR, it is similar to the triangle PST. So triangle PQR is similar to triangle PST. Okay. So I can say the ratio of PQ, the ratio PQ 2PS. It must be proportional to QR upon ST. Now what is PQ? PQ here is nothing but that is 10 minus H. And the length PS, the entire height, it is equal to 10. Is equal to QR. What is QR? That is R. And what is ST? The radius of a cone, which is 4. So if you solve this equation, what will I get here? You can simplify this. I'll get 10 into 4, that is equal to 40 minus 4H is equal to 10. Or from here, I can say that is 4H is equal to 40 minus 10R. Or H is equal to nothing but that is 10 minus 2.5R. So height is equal to 10 minus 2.5R in terms of radius here. Alright. Now, we need to find out the total surface area. So what is the formula for total surface area? Total surface area of a cylinder. Largest possible total surface area of a cylinder. So the total surface area of a cylinder, it is simply equal to how much? That is 2 pi RH. 2 pi RH plus 2 pi R square. So you can substitute the value of H in terms of R. So here I can take 2 pi as common. Okay. And R into H. So R into H is what? That is 10 minus 2.5 R. Okay. Plus R square. That we can do it here. So this implies that is equal to 2 pi into. That is 10 R minus 2.5 R square. So I'm writing step by step. 10 R minus 2.5 R square plus R square. So this implies this is equal to 2 pi into how much? That is 10 R minus 1.5 R square. Now after that, I need to what? I need to maximize this. So there are several ways in which we can work it out. Okay. So basically our target is to maximize this value. Now if you observe this, one of the ways you can use differentiation, and with differentiation you can find out the answers quickly. Or if you observe this, this is nothing but a quadratic equation in R. So you can use either the formula of a quadratic equation or you can use the differentiation. Okay. So if I am using the differentiation here, remember 2 pi is constant. Okay. So I'll say, what is this? This is equal to nothing but T. Total surface area is equal to T. So if I differentiate it, then I'll get dt upon dr. And dt upon dr, 2 pi the constant will be here. And 10r, the differentiation of this is 10 minus 1.5 r square. So the differentiation is 1.5 into 2, which is 3r. That's it. And make it equal to 0. And if I equate this equal to 0, I'll get the value of r, which is equal to 10 by 3. And once we get r equal to 10 by 3, you can substitute this in your answer to get the answer. Okay. Like if I substitute r equal to 10 by 3 here in the total surface area, this formula, which you have got it here. So what will I get here? That total surface area is equal to 2 pi into 10 pi by 3. Okay. So 10 pi by 3, so that is equal to nothing but that will be comes out to be 10 into 10 by 3. R is 10 by 3 minus 1.5 into 10 by 3. So 1.5 into R square, which is equal to 10 by 3 whole square. Okay. And solve this and get your answers quickly here. Okay. So this is the one of the way by using a differentiation. If you solve this, if you equate this, I think you will get the answer as nothing but option number A, which is equal to 100 pi by 3. I am sure that you all can solve this. Now, the other way which I told you, you can also solve it without using this, without differentiation also. So let me solve it and show you how we can solve it without differentiation. If I do not want to differentiation, or if someone who is not from the maths background or who have never studied differentiation, then you can use the simple approach of quadratic equation. So as this is a quadratic equation, and we know that for any quadratic equation, if the quadratic equation is in the form of ax square plus bx plus c equal to 0. Okay, or I'll say, let's say x square plus bx plus c. So for any quadratic equation, the maxima or minima, it will always exist at x equal to minus b by 2a. That is the point here. So at it will always exist at x equal to minus b by 2a. So in this case, my equation is nothing but that is 10r minus 1.5 r square. So the minimum value or the maximum value, as the coefficient of r square is negative, so there exists a maxima. So maximum value will exist at r equal to minus b. So this is 10. B is 10 here. So minus 10 upon 2a, that is 2 into minus 1.5. So I'd say minus 2 into 1.5. And you can see the radius here is again 10 by 3. So you can use any of the approach. Of course, if you know just a very basic of differentiation, okay, then a lot of questions like similar to this can be solved quickly. So if we substitute r is equal to 10 by 3, we'll get the answer which will be comes out to be 100 pi by 3. So the correct answer for this question, it is nothing but that is 100 pi by 3. Okay, so I can highlight this 100 pi by 3. So I hope that all these three questions are clear to all of you, and you also know that what is the importance of knowing the maximum minimum concept in the mensuration topic here. Okay. And similar type of the question was also asked in CAT 1999 and also one more here. Okay, so make sure you are comfortable with solving maxima and minima in geometry. Okay. Now, we are also starting our freebinar series. Freebinar means what? Freebinar is free webinar. We have coined this term in 2013. We started teaching online live classes from 2013. In fact, we are the first one to start the live classes for CAT. That too around 7 years back. So freebinar for this year has also started. Okay, wherein we'll take a lot of free webinar for different topics, English, DILR, Quant, and so on. Okay. So to get information regarding the free webinar or how to attend the free webinar, you can join our WhatsApp group or our Telegram group, which is given in the description. Okay. So once you join our WhatsApp group and Telegram group, so we'll keep posting the link of the free webinar. So like the next webinar is on Sunday, that is a vocabulary, that is completely free. So you guys can attend it. So thank you and see you tomorrow. Tomorrow again, I'll take few more interesting questions, few more conceptual questions. Thank you.